here we go. So, the amount of CO2 in the air determines how much heat you're going to get, okay? And that means we need to know what gets CO2 into the air. Other than us, what is the main thing that puts CO2 into the air on Earth? What's the main natural source of CO2 on the planet other than us? Yeah, a lot of you guys are basically at least beating around the bush on it. It's essentially volcanoes, okay? So there is CO2 in the rocks that make up the crust of our planet. It's trapped in those rocks. And one way for that CO2 to get out is to melt those rocks. And so one of the type of gases that shoots out of volcanoes is CO2. So on our planet and on Venus, CO2 is coming out of volcanoes. This is a volcano right here. CO2 is coming out. Now, does anybody know what the main thing that takes CO2 out of the air is? Well, I think some of you guys are actually getting it here. Some people have said the ocean. How does it get into the ocean, though? How does it come down out of the air into the ocean? Oh, and some of you guys are saying things like trees and plants, and they definitely help. They do play a big part on Earth, but they actually are outdone by the thing that gets the CO2 out of the air and into the ocean. Let me help. It's rain. Rain is the main thing that takes CO2 out of the air, okay? And the reason that works is that when a cloud forms in the sky, it doesn't just have water in it. Any gases that are in the air will get trapped in those water droplets. And when those water droplets fall down, they take that material down back into the ocean, which eventually and the material in the ocean eventually works its way back down into the rocks as well. So we essentially have a cycle where things like volcanoes are putting CO2 up, and then things like rain and plants are bringing it down. Okay? And some people say that we don't need to worry about the amount of CO2 we're putting up into the air because volcanoes are putting a lot into the air. But that doesn't really make sense because on Earth, the amount of CO2 that's coming down from natural processes like rain and plants and bacteria and other life forms is roughly balanced by the amount that comes out of CO2. That comes out of volcanoes. So the amount coming up out of volcanoes is balanced by the amount that comes down by clouds and plants. So if those two things are balanced, what happens to the amount of CO2 in the air over time? Yes, it stays roughly the same. And that doesn't mean it's always been exactly the same over millions and millions and millions of years. Sometimes a tiny bit more is going up than down. So that means the temperature would go up a little bit. And sometimes a little bit more CO2 is coming down than up. And that makes the temperature go down a little bit. But on average, they've stayed roughly equal for billions of years. So why do we care about the amount that comes out of things like cars and power plants and all of that? Well, if the process other than us is roughly equal, down and up, even if we only put out a little bit of CO2, that puts it out of balance, right? So it's kind of like even if we don't put out much in a year, imagine somebody kidnapped our entire class. Okay? Imagine somebody kidnapped our entire class and kept us locked in a room for years and years and years and years and years. And this was just like a sealed ecosystem. Like, he was never going to let us out. And this crazy kidnapper, mad scientist guy who set this whole thing up came inside of this room with us once a day and farted in the corner. Okay? He came into the room and farted in the corner. Is that one fart really going to be a problem for us? Is that one fart going to be a problem? Sorry for the weird example. No, that one fart is not going to really be a problem. But what if in this sealed system he came in and farted in the corner once every day, okay? Every single day. What's going to slowly happen to the fart content in this trapped space that we're in? Depends on what he ate. Yeah, maybe so. But yeah, if he, at first, we won't really notice the farts unless you're standing like right next to him or he's just really bad. But over time, the entire environment would slowly fill up with farts. It would accumulate and we'd be farted out, okay? Just way too many farts in here. That's what we're doing with the CO2 we're putting into the air. Even if we don't put that much in the into the air in a given year, it slowly builds up over time, and if there's more CO2 in the air, it makes things hotter, okay? And this is all a simplified version of it. If you want the real full details of exactly how this works, take either a climatology class or a geology class. They also talk about this. Now, so what's different on Venus? Here we go. What's different on Venus? Now, let's talk back to when the planets very first formed, okay? The planets have just formed, okay? When the planets had just formed a little over 4 billion years ago, Earth and Venus were actually a lot more similar, okay? So we're about the same size, so the heat inside of our planets is similar. So what does that mean for the amount of volcanic activity in a given year on Earth and Venus, probably? If we have about the same amount of heat content inside, what we expect about the amount of volcanic activity in a given year? About the same. That's correct. We expect the amount of volcanic activity to be roughly the same, and that would have been true right when the planets had started, because we've always been roughly the same size. But what was true about the surface temperature of Venus even then? So when we first started out, our internal temperature was about the same, so the amount of volcanoes would be roughly the same. But Venus is closer to the sun, so what's the surface temperature going to be like compared to us? Hotter. That's right. It would be hotter on Venus because it was closer to the sun. Now, at this point in the history of Venus, it probably had an ocean just like we did, or that we do still, made out of water. So it would have had rain and clouds and a whole precipitation cycle just like we do. But because the surface temperature was hotter, does anybody know what that would do to the amount of rainfall? Would it stay the same as on Earth? Would it be less rainfall or more rainfall if the surface temperature was hotter? Now this one's a little bit tricky. I'm getting both less and more. So Would it be easier or easier or harder for water to evaporate if it was hotter? It would be easier. But here's the thing. If it's easier for water to evaporate, that means that water is going up more than it's coming down. So the amount of rainfall actually would have been less to a pretty extreme amount on Venus than it is on Earth. And that's important because on Earth, I said that the amount of CO2 that was coming down from from rain, is pretty close to the amount of CO2 that's coming up from volcanoes. It's not exactly the same because plants do play a part on Earth, but are there any plants on Venus? No. So that means on Venus, things were not balanced. So was more CO2 going up or was more CO2 coming down on Venus than on Earth? So up or down? Did Venus have more CO2 going up or down? Yes, that is correct. More CO2 would be going up because the amount of volcanoes was roughly the same as on Earth, but the amount of rainfall was less. So since the amount going up was about the same as on Earth, but the amount coming down was less, the amount of CO2 in the air on Venus increased over time. Okay? So on Venus, the amount of CO2 increased over time, and what would that do to the temperature over time on Venus? If the amount of CO2 was increasing, what happened to the temperature on Venus over time? It also increases. That is correct. That is correct. So Venus slowly got hotter over time. But if it got hotter over time, then what happened to the amount of rainfall over time? It went down. Yes, that is correct. But if the amount of rainfall went down, then that means things got even more unbalanced over Venus. And so more water kept evaporating, which made the process get worse and worse. Okay, so over time, the amount of CO2 kept increasing on Venus, and that made it hotter, and that made it even hotter for rain to fall back down. Okay, and so what do we think eventually happened to the entire ocean on Venus? Here's a hint. Does Venus have an ocean today? No. So what happened to that ocean, or at least a large part of it? Yeah, it entirely evaporated. So the reason Venus doesn't have an ocean anymore is it got too hot. And so remember, if the entire atmosphere evaporated, what should happen to the amount of clouds? Sorry, if the entire ocean evaporated, what should happen to the amount of clouds in the atmosphere? It increases. And what do we see all over Venus? Tons and tons and tons of clouds. Okay, so that all makes sense. All right, that all makes sense so far. Okay, now, at that point, some of you guys mentioned that this was a runaway greenhouse effect, but it's not quite runaway yet in this story. Okay, so a greenhouse effect is called runaway when a specific thing starts to happen. And that specific thing is this. The reason that there is CO2 coming out of the volcanoes is because CO2 is trapped in the rocks that make up the crust. Now, here's a question I have. Have any of you guys ever done pottery? And if you have, when you've shaped your clay into whatever you're trying to make, what do you have to do to that particular piece of pottery to make it stay in that shape? When you're done shaping it, what do you do with your sculpture? Oh, and there might not be anybody here who is yeah. So there you go. You fire it. You put it in basically in an oven, and that oven dries the rocks out. Now, what's actually happening there is any liquids. The reason that clay is easy to shape is because it has a lot of liquid trapped in it, usually water, right? And when you put that clay in an oven, it dries it out by essentially what happens is that all of the liquid and gas that's trapped in that rock is released from the rock, drying the rock out. If you were to bake a rock that had a lot of CO2 in it, some of that CO2 would come out, okay? And some of you may be seeing where I'm going with this. If the temperature on Venus kept getting hotter and hotter and hotter, eventually the surface temperature of Venus everywhere was as hot as an oven, like the kiln. It's a special type of oven for pottery. And when it got that hot, that meant that the rocks on the ground started to bake like in an oven. And what will start to release directly out of those rocks? What's trapped in those rocks that baking them will release? What's going to come out of those rocks? Yeah, I'm seeing two things. If there was any water left in those rocks, it definitely evaporated out. But what I'm getting at is the CO2 that's trapped in those rocks will start to just come out. And it's at that part that you call it a runaway greenhouse effect. Because if CO2 comes directly out of the ground, you don't even need the volcanoes anymore. Because now the temperature of the atmosphere is making its own CO2 out of the ground. And if CO2 comes out of the ground, what will happen to the temperature? Yes, it will get even hotter. And what that does is it causes, so CO2 comes out of the ground, which makes the atmosphere hotter, which makes more CO2 come out of the ground because now it's baking hotter, which makes more CO2 come out, which makes it hotter, which makes the ground bake worse, which makes more CO2 come out, which makes it hotter. And this keeps on going, and it just gets worse and worse and worse and worse. And that's why it's called a runaway greenhouse effect. So Earth doesn't have a runaway greenhouse effect because we are not that hot yet. Now, here's a quick question. Will Earth ever have a runaway greenhouse effect from our actions? Okay, so I'm seeing a lot of people say that it could. And here's the thing. It won't. Human beings cannot make the greenhouse effect on Earth a runaway greenhouse effect. But that doesn't mean we're going to be okay. Because check this out. How hot does the Earth have to get to be a runaway greenhouse effect? How hot would the Earth have to get to be a runaway greenhouse effect? As hot as an well, as hot as an oven, essentially. And now here's my follow-up question. So in order to make our greenhouse effect runaway, we would have to get the temperature up to an oven temperature. Would we, as human beings, be alive on this planet if we got it as hot as an oven? No. So be very clear about what I'm saying here. I'm not saying we're not causing a problem. I'm just saying that we will never make this quite to a runaway greenhouse effect, because as we continue to heat the environment, if we ever got anywhere close to a runaway greenhouse effect, we would all die. And if we all die, we stop making the environment hotter. So the only reason that we will never get to a complete runaway greenhouse effect is if we got anywhere near a runaway greenhouse effect, we would all die and we would stop making it hotter. So the Earth will probably not have a runaway greenhouse effect in that case. If we get anywhere close, we'll just be dead, and the Earth will adjust. So good luck with that.